Ever looked up at the sky and wondered how the sun could just vanish for a few minutes as a powerful star fuels our world and then boom, gone? How can something 400 times smaller than the sun just block it out completely? It's kind of wild, right? What's the cosmic magic behind that? Well, today we're going to unlock those mysteries. We're going deep into the world of eclipses. We'll explore how Earth and the Moon move, figure out the science behind solar and lunar eclipses, and see what makes each type unique. So, to get eclipses, got to understand how Earth and the Moon dance around. Picture Earth on a year-long trip around the sun. It's not a perfect circle, though. It's more of an oval, an elliptical path. And this orbit takes about, 365 days and 6 hours. But Earth's not alone in this cosmic waltz. The Moon's there, too, our trusty sidekick. It orbits our planet, doing a full lap every 27.322 days. Now imagine this. The new Moon, while it's cruising around Earth, lines up perfectly between the sun and us. At that exact moment, bam! The Moon blocks the sun's rays, casting a shadow right on Earth. That, my friends, is a solar eclipse. Now, I know what you're thinking.
Wait, the moon's tiny compared to the sun. How can it block it out? And you'd be right to think that. The moon is about 400 times smaller than the sun. But, and here's where things get interesting, it's also about 400 times closer to us. It's a cosmic coincidence that makes them look roughly the same size in the sky. And that's how the moon can seemingly cover the sun, creating that incredible solar eclipse. But here's another thing. The moon's shadow isn't big enough to swallow the whole Earth. It only covers a certain area. And because everything's constantly moving, even during an eclipse, this area is always shifting. That's what creates what we call the path of totality. It's like a band across Earth, where you could see a total solar eclipse. Now, about those shadows. When the moon eclipses the sun, it throws two kinds of shadows on Earth. First one's the umbra. It's small, super dark, where the sun's completely blocked. If you're lucky enough to be in the path of totality under the moon's umbra, you'll witness the full glory of a total solar eclipse. The other shadow is the penumbra. It's bigger, a bit lighter, and it surrounds the umbra. Here, only part of the sun is blocked, so you get a partial solar eclipse. We've talked about total and partial solar eclipses, but there's more to this celestial show. Two other types of solar eclipses make this cosmic dance even more dramatic. First up, the annular solar eclipse. This happens when the moon goes right through the sun's center, but doesn't cover it all. See, the moon's a tad farther from Earth during an annular eclipse, making it look a bit smaller than the sun. So you get this awesome ring of sunlight around the moon. It's like a ring of fire in the sky. And then there's the rarest of them all, the hybrid solar eclipse. They call it hybrid because it switches between total and annular depending on where you're watching from on Earth. Imagine some places see total darkness, a total eclipse, while others, because of Earth curve, see that fiery ring, an annular eclipse. Just shows how complex these distances and movements are in our solar system. So we've seen how the moon can eclipse the sun. But can Earth do the same to the moon? Totally. That's what we call the lunar eclipse. It happens when Earth gets right between the sun and the moon, throwing its own shadow on the moon. Now, the moon takes roughly 27 days to circle Earth once. But from our perspective, it seems like it orbits every 29 days. That's because Earth's spinning and moving around the sun, too. And just like with solar eclipses, Earth casts two types of shadows on the moon during a lunar eclipse, the umbra and the penumbra. The most dramatic lunar eclipse is the total lunar eclipse. Everything lines up perfectly, Earth, moon, and sun. The moon falls completely into Earth's umbra. No sunlight reaches the moon, so it looks like it's turning a deep reddish color. It's called a blood moon, and it happens because sunlight filters through Earth's atmosphere and bends towards the moon. Then there's the partial lunar eclipse. This is when only a part of the moon goes through Earth's umbra. You'll see a clear shadow on one side of the moon like someone took a bite out of it. And lastly, there's the penumbral lunar eclipse, the most subtle one. Here the moon passes through Earth's penumbra, so it dims just a bit. You might not even notice it if you weren't looking for it. Now here's a safety tip. Lunar eclipses are totally safe to watch with your naked eyes. No need for special gear to enjoy the show. But, and this is important, never ever look directly at a solar eclipse without proper eye protection. It's super dangerous and can hurt your eyes permanently. The sun's light is powerful. It's got all sorts of radiation, including UV rays that can damage the cells in your eyes. So if you ever get to see a solar eclipse, make sure you've got certified eclipse glasses or use a safe method like a pinhole projector. From ancient folks who saw eclipses as bad omens to us modern-day skywatchers who appreciate their scientific beauty, these celestial events have fascinated people for ages. They show us how incredibly precise and clockwork-like our universe is. What used to scare people now brings us together in awe. We've journeyed through how Earth and the moon dance, explored the science behind their shadows, and discovered all the different types of eclipses we see in the sky. But our exploration doesn't stop here. We'll keep digging into the mechanics of eclipses, learning about their paths, how long they last, and what makes each one special. Stay tuned for more cosmic insights. Back for more on our cosmic adventure. Picking up where we left off, diving deeper into how eclipses work. We talked about the moon's orbit. It's not a perfect circle. It's more of an oval, a little bit elliptical. So sometimes the moon's closer to Earth, sometimes farther away. And that distance, it really matters for what kind of solar eclipse we see. Remember the total solar eclipse, when the moon completely blocks the sun? Well, those happen when the moon's closest to Earth. Think of it like holding a coin out in front of you.
Yeah.
Then bring it closer to your eye. The coin looks bigger, right? Same with the moon. Its size in the sky changes depending on how far away it is. When it's closer, it looks big enough to cover the whole sun. Boom, total eclipse. But what if the moon's farther away from Earth? And an eclipse happens then. Well, even if the moon passes right through the middle of the sun, it won't cover it all up. Because it's farther, it looks smaller in the sky, so you get this ring of sunlight around the moon. That's the ring of fire, the annular solar eclipse. Pretty cool, huh? Now let's think about those shadows, the umbra and penumbra. How do they move across Earth during a solar eclipse? You might think they just stay put, but nope, remember, everything's always moving. Earth's spinning, the moon's orbiting Earth, and Earth's going around the sun. It's a lot, right? A real cosmic dance. All this movement means the moon's shadow doesn't just sit still. It sweeps across Earth, making that path of totality we talked about. Like imagine drawing a line on a spinning globe. That's basically what the moon's shadow does during a solar eclipse. Now, the path of totality, it can be wider or narrower, depends on the eclipse. But usually it's about 100 miles wide. And get this, because Earth's spinning, the shadow moves east super fast, about 1,000 miles per hour. So if you're lucky enough to be in the path of totality, you get to experience a total solar eclipse. It's short, just a few minutes, but it's unforgettable. The absolute longest a total solar eclipse can last is about 7.5 minutes. And if you're outside the path, in the penumbra, you'll see a partial solar eclipse. Okay, we spent a good chunk of time on solar eclipses. Let's switch gears, talk about lunar eclipses. Remember, that's when Earth gets between the sun and the moon, casting its shadow on the moon. Now, solar eclipses, you can only see them from a narrow path on Earth. But lunar eclipses, you can see those from anywhere on Earth where it's nighttime. That's because Earth's shadow is way bigger than the moon's, so it covers a much larger area. So if you're on the side of Earth facing the moon during a lunar eclipse, you've got a front row seat. And remember that reddish color the moon gets during a total lunar eclipse, the blood moon. That's Earth's atmosphere doing its thing. Sunlight passes through our atmosphere, and the blue and green light, the shorter wavelengths, get scattered away. But the red and orange light, the longer wavelengths, they bend, they get refracted towards the moon. It's like, think about a sunset. You get those beautiful reds and oranges because the sunlight's going through more of Earth's atmosphere. Same idea with a lunar eclipse. Earth's atmosphere is like a giant lens bending that red light toward the moon, giving it that spooky red glow. You might be wondering, if Earth goes between the sun and moon every month, why don't we get a lunar eclipse every month? Good question. The moon's orbit around Earth, it's tilted a little, about 5 degrees, compared to Earth's orbit around the sun. So most of the time, the moon misses Earth's shadow completely.
It's a cosmic near miss. It's only when the moon's orbit lines up just right with Earth's orbit, at points called nodes, that we can get eclipses. And for a total lunar eclipse, the moon has to be at or very near a node during a full moon, when it's directly opposite the sun from Earth. It's like all the pieces have to fall into place perfectly. So there you have it, a closer look at the magic of both solar and lunar eclipses. We've seen how distances, movements, even Earth's atmosphere all come together to make these incredible events happen. But our journey's not over yet. In our last segment, we'll uncover some truly mind-blowing facts about eclipses. We'll look at their history, and we'll talk about why they continue to fascinate us. Stick with us. And we're back for the grand finale of our eclipse exploration. We've talked about the how, the types, the shadows, the whole shebang. But there's still more to discover. Get ready for some seriously mind-blowing facts about these cosmic wonders. Did you know a total solar eclipse can actually make it get colder? Like noticeably colder. It's true. During totality, when the sun's completely blocked, the air temperature can drop by as much as 10 degrees Fahrenheit. You might even feel a little chill, like a cloud just passed over. And here's another cool thing. Animals often act super weird during a total solar eclipse. Birds might stop singing, nocturnal animals might come out thinking it's nighttime, even pets can get all confused or anxious. It's like a reminder that we're all connected to nature's rhythms, and even a short interruption like an eclipse can throw things off. Now let's talk history. Eclipses have been observed and documented by cultures all over the world for centuries. Imagine ancient China.
A solar eclipse happens and people freak out. They think a dragon's eating the sun, so they bang drums and gongs to scare it away. In ancient Greece, a solar eclipse was a bad omen, a sign of war or famine coming. And lots of cultures believed eclipses were like a super spiritual time when the line between the physical world and the spirit world got blurry. Fast forward to modern times, and eclipses become super important for science. Like back in 1919, during a total solar eclipse, astronomers were able to prove Einstein's theory of general relativity. You know, the one that says gravity can bend light? It was a huge deal. Changed how we understand the universe. And even today, scientists use eclipses to study the sun's corona. That's the outer layer of its atmosphere. Usually it's too faint to see, but during a total solar eclipse, the moon blocks the sun's bright light, and boom, scientists can study the corona. They can learn about its temperature, what it's made of, its magnetic field, all sorts of cool stuff. But eclipses aren't just science. They're like reminders of our place in the universe. They show us that we're part of something much bigger. This cosmic dance has been going on for billions of years. Think about it. We could predict eclipses down to the minute. That's amazing. It showed the power of human observation and the laws of physics that run the universe. And the fact that we can travel to see totality, to stand in the moon's shadow and watch this incredible thing happen, it shows our curiosity, our need to connect with something bigger than ourselves. So next time you hear about an eclipse, don't just think, oh, cool. Think of it as an invitation, a chance to go outside, look up, and feel awe and wonder at this incredible universe we live in. And remember, every eclipse is unique, a one-time event that'll never happen again in the exact same way. So take the opportunity to witness these cosmic wonders. Let them inspire you to keep exploring, keep learning, and keep reaching for the stars. And that brings us to the end of our eclipse deep dive. Thanks for joining us on this cosmic journey. We'll catch you next time.